Notes 23. Slope reminders and graphing in the form of y equal mx plus b. Slope is the slant of the line. We found it two different ways. One way was given a line, we used rise over run. So for instance, over here on the graph, we would rise 1, 2, 3, 4, 5, 6, and we would run 1, 2, 3, 4. So 6 over 4 reduces to 3 over 2. Another way we've done this is given the two ordered pairs listed there. So you can either do 3, 2 as your first order pair or 7, 8 as your first order pair. It really makes no difference. Either way, you're going to circle the second number. So circle, circle, dash, line, dash. So I've got 8 minus 2 right here as my y values, and then 7 minus 3 as my x values. So that gives me 6 over 4, which reduces to 3 over 2, which is the same thing. All right, so let's go ahead and now we're going to go and graph a line using the slope-intercept form, y equal mx plus b. Graphing lines using the slope-intercept form, remember that the first number listed next to x is your slope, and then the second one listed by itself is the y-intercept. So what we're going to do here on step 1, the first point will be the y-intercept. So the number is placed on the y-axis at 1, which is right there. And step 2, the second point, look at the slope, the m from the equation. So count up and over or rise over run from the y-intercept. So do this at least 2 times to get at least 3 points along the line. So if our slope is 3, we make that a fraction of 3 over 1. So we're going to go up 1, 2, 3, over to the right 1, and put a point. And we do that again. 1, 2, 3, and over to the right, and we put a point. So this is what our line would look like. All right, so we're going to go practice on the back side. So problem number 1 on the back, we start at -2. As your y-intercept, we're going to go up 1 over 2. Up 1 over 2. So this is what our line would look like right there. This is problem number 1. And so you would have to identify that the slope is 1 over 2 and that the b is -2. On problem 2, we're going to have our b is -4. That's where we begin. So it'd be -4 right here. And your slope is -1/2. So I'm going to go down 1, right 2. Down 1, right 2. And you can keep going if you want, down 1, right 2. So the line would look like this. So this is problem number 2. All right, problem number 3, our b is 4. Our slope is a 1, so that means 1 over 1. So we're going to start here at 4 on the y-axis, and then we're going to rise 1, run 1. Rise 1, run 1, rise 1, run 1. Okay, so this is problem number 3. All right. Problem number 4, if we don't have a y-intercept, it's understood to be 0. And then our slope is -3 as a whole number, which means -3 over 1. So we're going to start at 0, and then we're going to go down 3, 1, 2, 3, and right 1. We can do that again, down 1, 2, 3, and right 1. So that's what our line would look like there for problem number 4. All right, let's take a look at problem 5. Again, if our y-intercept's not there, it's understood to be 0. Our slope is 2, which means 2 over 1. So we're going to start at 0 and then go up 2 over 1. Go up 2 over 1, up 2 over 1. You can put as many points as you want. It really does not matter. So this is problem 5. All right, problem 6. Our y-intercept, our b, which is where we begin, is at -4. Our slope is 2, which means 2 over 1. So we're going to begin at -4, and then we're going to go up 2 over 1. up 2 over 1. You notice the lines are parallel. The lines are parallel because they have the same slope. Number 7, there's no y-intercept, so it's understood to be 0. Your slope is 3/4. So we're going to start at 0 and go up 3 and over 4. Now you notice I can go up 3, but I can't go over 4. So I'm going to back it up. All right, so it's like I'm going to make this a -3 over a -4. So a negative over a negative is a positive. So I'm going to go down 3, left 4. So that's problem 7. All right, problem 8, my y-intercept is 5. My slope is -1, so that means -1 over 1. So I'm going to start up here at 5. And I can go down 1, right 1, down 1, right 1. I can keep doing that, down 1, right 1. So that's what that one looks like on problem number 8. All right, moving on. Oops. Moving on up over here. Let's take a look at problem 9. Our y-intercept is -3. Our slope is 5, which means 5 over 1. So we're going to start at -3, and then we're going to go up 5 and over 1. 1, 2, wait, we're at 2. So if I go up 5, that's going to put me at 7 and then over 1. So this is problem 9. All right, problem 10. Your y-intercept is -3, just like on problem 9. So you're going to start at the same place, but the slope is 1, so that's 1 over 1. So we're going to start at -3 and then go up 1, right 1, up 1, right 1, right 1, up 1. You can keep going. There you go. All right, so this is problem number 10. All right, let's take a look at problem 11. The y-intercept is 1. The slope is 1/3. So we're going to start at 1 and then go up 1 and over 3. Go up 1, 1, 2, and over 3. All right, so that's problem 11. Problem 12, our y-intercept is -2, and our slope is -3, which means -3 over 1. So we're just going to start at -2, and then we can go down 1, 2, 3, right 1, 1, 2, 3, right 1, or you could also go up 1, 2, 3, left 1, 1, 2, 3, left 1, just whatever you want to do there. Now, I want to talk about this just a little bit. It says talk about parallel. So parallel lines have the same slope. I talked about that earlier. Perpendicular lines will be like problem 11 and 12, where the slopes are, they're opposite signs. So opposite signs and flipped or reciprocated. So if you look at the slope here on M, you see that it's 1/3. And so you look at the slope on number 12 and you see that it's -3 over 1. So there's opposite signs. One's a positive, one's a negative, and the fraction's flipped. It goes from 1/3 to -3 over 1.